video, I want to start with talking about an anatomical structure which is known as the pleura that surrounds the lungs, and then finish up by talking about what's known as pulmonary ventilation or breathing. If you look at this diagram here, what we've got is the thoracic cavity cut in cross section, so you can see both of the lungs and the heart as if you're looking down on them. The pleura is a double-layered serous membrane that surrounds each of the lungs. So it's similar to the pericardium that we learned about previously that actually surround the heart. If you look here, I'm running my pointer along a kind of dark blue colored line or membrane that direct contact with the thoracic cavity wall. And this is the outermost layer of the pleura. It's what is known as the parietal pleura. You'll notice right here where I've got my pointer that the parietal pleura kind of folds over on itself, and then it's in direct contact with the lung itself. And here it's represented in kind of this reddish color. So this innermost layer of the pleura that's in direct contact with the lungs themselves is what's known as the visceral pleura. Visceral because viscera is a term that means organs. And so the visceral pleura is the part of the pleura that's in direct contact with the lungs or with the organs. In between those two layers of the membrane, you'll notice that there is kind of a light blue colored space, which I'm running my pointer across now. This particular area is what's known as the pleural cavity. And really it's just kind of a slit-like cavity between those two membranes. It's filled with an oily lubricating fluid, which is known as serous fluid. So the pleural cavity and the serous fluid that is located within it is really important to reducing friction in the thoracic cavity. If you think about the thoracic cavity, the heart's in there, it's contracting, it's relaxing. As it's doing so, it's expanding and shrinking back down. So it's a very mobile organ. The lungs are doing the same thing. So as they fill with air, they're expanding. When you exhale, they're contracting back down. So there's a lot of movement that's associated with the lungs as well. Having this oily lubricating fluid, which is known as serous fluid, surrounding the lungs within that pleural cavity is going to help to reduce friction as the lungs are moving, as they are inhaling and exhaling, and as the heart's moving as well. So it's protective to the lungs in that it encases them and it reduces friction on the lungs themselves from other structures that are located in the thoracic cavity. The other thing that's important about the pleura, you can notice this if you look at the diagram, is that each of the lungs is compartmentalized into its own separate pleura. So the pleura isn't continuous between the lungs, and this is really important for helping the lungs to stay inflated, as you'll learn about in the activity that you're going to do this week. So I mentioned I wanted to talk a little bit about the pleura, and then we'd get into some mechanics of the lungs and start talking about pulmonary ventilation, which really is just a fancy term for breathing. So pulmonary ventilation or breathing is the ability of the lungs to move air inside of them when we inhale and also expel air when we exhale. So basically it's the process of breathing, and it's completely dependent on lung mechanics. And we'll get to that with the end of this lecture. But before we get into that, I want to tell you about a couple of different pressures that actually influence pulmonary ventilation and allow us to be able to inhale and exhale. And the first of these is what's known as atmospheric pressure. So atmospheric pressure is the pressure of the atmosphere around us. It's the pressure of the air that surrounds our body. It's the pressure that's located outside of our bodies. The other pressure that breathing is mediated by is what's known as intrapulmonary pressure. So intrapulmonary pressure, as its name implies, is pressure within the lungs. And basically, so that you don't get bogged down into this, before I start getting into the details, breathing works like this. When pressure in the lungs is higher than the pressure outside the body, you exhale, and air moves from an area of higher pressure to an area of pressure. When pressure in the lungs is lower than pressure outside of the body, and it's lower than the atmospheric pressure, air from outside the body moves into that area of lower pressure, which is within the lungs, and you inhale. So we learned about before that blood always moves from areas of higher pressure, areas of lower pressure. It's the exact same thing with air as it's moving into and out of the lungs. And really all we have to do in breathing is set up a situation where pressure in the lungs or intrapulmonary pressure is lower than atmospheric pressure when we need to inhale, and then set up a situation where intrapulmonary pressure or pressure in the lungs is higher when we need to exhale, because air is just always going to move from areas of higher pressure to lower pressure. So if you get bogged down in some of the details of this, come back to that and remember just that our air, always moves from areas of higher pressure to areas of lower pressure. So if the pressure is higher in the lungs than outside your body, it's going to be moving out. If the pressure is higher outside your body than it is within the lungs, and we're going to see air actually moving into the lungs. With that being said, so that's kind of the big picture. What I want to do is give you some additional information about both atmospheric pressure and intrapulmonary pressure, starting with atmospheric pressure. So I find that a lot of students aren't tremendously familiar with atmospheric pressure, and so I want to talk a little bit more about what that is and what's actually working to cause atmospheric pressure. And to do that, I've got a diagram here with a couple of stick figures that I've drawn in. This first one that's lower is representing someone that's walking along the beach at sea level effectively. And I want to focus for a minute on what's above somebody who's walking on the beach at sea level. Basically, we've got this column of air, right? Of air molecules that extend actually hundreds of miles up into the outer atmosphere. And that column of air or air molecules is made up of molecules which have a mass, they have a weight to them, and the collective mass or weight of all of those molecules is pushing down on your body, and that's what's creating the atmospheric pressure. You may have heard it said before that atmospheric pressure at sea level is equal to 760 millimeters of mercury. So if that's kind of confusing to you or you're not sure what that means, when scientists were first discovering atmospheric pressure and finding ways to describe it, they found that the atmospheric pressure, the pressure on our bodies, when you're at the coast, when you're at sea level, due to all of those molecules that are extending hundreds and hundreds of miles up into the air above you, pushing down on you, is equal to the weight of a column of mercury that's 760 millimeters high. So that's where that's coming from. If you like that, great. If that's just more confusing, that's totally fine as well. We all know how to count, right? So you know that if atmospheric pressure is higher than 760, that means it has increased. If it's lower than 760, that means it has decreased. And atmospheric pressure will increase or decrease depending on your elevation. So if you look at the second person that I've drawn in here, they are represented as standing on top of Mount Everest, which is at about 30,000 feet. And if you're standing on top of Mount Everest, one of the things that you'll notice is that column of air that's pushing down on your body is significantly shorter than the column of air when you're standing at sea level. So it's about 30,000 feet shorter because you've gone 30,000 feet up in elevation, right? But the other thing that you'll notice is that most of the air molecules tend to stay at lower elevations. And the reason for this is they're simply pulled there by gravity. So when you're standing on top of Mount Everest, atmospheric pressure really significantly decreases because there's not as much air up there. There is not as many air molecules in the column of air that's above your head pushing down on your body. So what we actually see on top of Mount Everest is that atmospheric pressure is about a third of the atmospheric pressure at sea level. So atmospheric pressure can change. If you're staying at the same elevation, it's basically staying the same. But if you go up in elevation or you go down in elevation, it's going to decrease or increase above or below that 760 millimeters of mercury, because that's just for someone who's standing at sea level. So that's an introduction to atmospheric pressure, maybe more than what you really needed to know about atmospheric pressure, but I want to make sure that we're all kind of clear on what it is, what's creating it, why it's one of these pressures that's actually mediated breathing. The other pressure that I mentioned before that is also working to mediate breathing is what's known as intrapulmonary pressure. So that's the pressure that's within the lungs, as I mentioned before. And there's a few things about this intrapulmonary pressure that you should know. But before we get into those, I want to remind you of that big picture thing. When pressure in the lungs is higher, when intrapulmonary pressure is higher than atmospheric pressure, air is going to move from the lungs to the outside of the body because it's just moving down its pressure gradient. It's moving from an area of higher pressure to an area of lower pressure. When the pressure in the lungs is lower than atmospheric pressure, you're going to inhale. Air is going to move from outside the body, from that higher atmospheric pressure to that lower intrapulmonary pressure that's inside of the body. And because of that, we can talk about the pressure in the lungs being positive, zero, or negative. So I want to draw a picture, I think, that can help maybe with some understanding of this. So here's a little graph for you. My line got a little wonky there. But let's say this line right here is right at 760. So that's our atmospheric pressure at sea level, right? And when you're breathing, basically your lungs are doing this, okay? So pressure in the lungs is going to become higher, and then it's going to equalize with atmospheric pressure, and then it's going to become lower than atmospheric pressure, and then it's going to become higher than atmospheric pressure, and then it's going to become lower. And when it's higher than atmospheric pressure, like you see here and like you see here, those are times when you're exhaling, when air is moving from an area of higher pressure within the lungs to an area of lower pressure. When the pressure in the lungs is lower than atmospheric pressure, like you see here and like you see here, that's when you're inhaling, because air is moving from an area of higher pressure outside the lungs to that area of lower pressure inside the lungs. So we talk about intrapulmonary pressure being positive when the pressure is higher than atmospheric pressure, like you see here. So that again is going to happen when you're exhaling. The pressure is negative, so intrapulmonary pressure is negative when the pressure in your lungs is lower than the atmospheric pressure. And that's going to happen when you're inhaling, when air is moving from the higher pressure atmospheric air into the lower pressure area within the lungs. In between times when we're inhaling and exhaling, the pressure is zero, which means it's equal to atmospheric pressure. So I've drawn in these little dots here where pressure in the lungs is equaling with atmospheric pressure, and it's actually zero. This happens during the pause between breaths. So if you look at this diagram again, to run kind of my pointer along what I mean, here pressure is increasing, you are exhaling, so you blow that air out. And then there's a pause, right, between breaths. And when that pause happens, we are equal to atmospheric pressure. And that's why the pause is actually happening, because the intrapulmonary pressure and the atmospheric pressure are equal to each other. We're not going to have air moving in either direction because there's not a lower pressure area in which it can move. Then you have to change the situation mechanically in the lungs to drop the pressure for or below the atmospheric pressure so that you can inhale. And as you're inhaling, you're drawing air into the lungs, and then there's that pause before you exhale. And the reason that pause is there because you're at a zero intrapulmonary pressure, which means that you're equal to the atmospheric pressure. And then you have to change, again, the mechanical situation in your lungs to create a higher pressure in your lungs so that you can exhale. And this is basically just a cycle that repeats and repeats with each breath that you take. So you should be familiar with these terms. Positive, knowing that that's a higher than atmospheric pressure. It occurs when we're exhaling. Negative is when the pressure within the lungs is lower than atmospheric pressure. It occurs when you're inhaling. And in between breaths, in between each inhalation and exhalation, there's a time period when the intrapulmonary pressure is equal to the atmospheric pressure. And when they are equal, we say that the intrapulmonary pressure is 0. So with these last couple of diagrams, what I want to do is talk a little bit about how the lungs go about generating these changes in pressure. So how do they get the pressure within them higher when you need to exhale? How do they get the pressure within themselves lower when it's time for you to inhale? And to be able to understand that, there's a relationship that you should understand between pressure and volume. And that relationship is inverse. So what I mean by that is when volume increases, I'm using this little arrow to represent an increase, V represents volume, that is going to translate into a decrease in pressure. And conversely, when volume of a container decreases, that's going to lead to an increase in pressure within that container. If you think about the lungs, they're basically a container that's full of air, and they follow this relationship. If you increase the volume of the lungs, the pressure inside of them is going to drop. If you decrease the volume of the lungs, the pressure within them actually increases. So all we have to do to create a positive intrapulmonary pressure so that you can exhale is decrease the volume of the lungs so that we increase the pressure within the lungs. All you have to do in order to be able to inhale to get that negative intrapulmonary pressure is increase the volume of the lungs so that you decrease the pressure within the lungs and drop that pressure within the lungs below the atmospheric pressure. And when you do that, air is going to naturally move into that area of lower pressure. So with this first diagram here, what I've got represented for you is inspiration. So that's just another name for inhalation, right? Breathing in. And specifically, this is inhaling under quiet situations. So what I mean by that is you're not exercising, you're not out of breath, you're not gasping for air. You're sitting there, you're calm, you're relaxed, you're peaceful, just peacefully breathing in and out. That's what quiet breathing is. And this is how quiet breathing and quiet inspiration actually happens. So if you look at this diagram over here, we've got the rib cage represented, and there's a couple of muscles that you should be familiar with that are really important for inspiration. So the first of these is the diaphragm. And the diaphragm you've learned about before. It actually forms the boundary between thoracic cavity and abdominal pelvic cavity. If I were to draw the lungs in, they kind of look like this. So here's lungs. Here's the other one. And the diaphragm's attached into the lungs, and it's kind of dome-shaped up like this. And what happens when you begin to inhale is the diaphragm goes from its relaxed position into its contracted position. And when it contracts, it actually moves down in this direction and it flattens out. And as it does so, it's going to pull on the lungs and it's going to expand them longitudinally. So the volume of the lungs is going to increase in this direction longitudinally as the diaphragm increases the volume by flattening out. The other muscles that are important in breathing in are the external intercostals. So these are also muscles that you should have learned in 227. They're muscles that sit in between each of the ribs. So we've got a superior rib here. Here's the inferior rib to it. External intercostals are running between those two ribs. And when you breathe in, the external intercostals contract as well. And as they do so, they pull those ribs and they cause the rib cage to flare out. So go ahead and look at yourself taking a deep breath right now. you'll notice that your rib cage expands, and that's due to the external intercostals contracting and pulling the ribs below them out. But what that's going to do is it's going to increase the volume of the thoracic cavity in the horizontal plane as well. So we're getting this increase in volume of the thoracic cavity and of the lungs. And as we talked about previously, when volume increases, pressure is going to decrease. What we need to do with the lungs is increase the volume just enough to drop the pressure about 1 millimeter of mercury below atmospheric pressure. So if you're walking on the coast, atmospheric pressure is 760, we need to increase the volume of the thoracic cavity in the lungs just enough to make that intrapulmonary pressure 759. And when you do, now we've got enough of a pressure gradient that air is going to start to move from the higher pressure area outside the body to the lower pressure area inside of your lungs. And of course, as air is moving into the lungs and more air is building up in the lungs, that's going to start to bring the pressure in the lungs back up until it hits 760 and we're at a 0 intrapulmonary pressure, and that's when your inhalation is going to stop. Exhalation or expiration, at least in a quiet breathing situation, which means again, that you're not gasping for air, you're not blowing out birthday candles, you're not exercising, you're not having an asthma attack. You're just sitting there calmly, peacefully breathing in and breathing out. In that case, expiration is just the reverse of inspiration. Inspiration requires the contraction of the diaphragm and the external intercostals, as we talked about. So there is some energy expended in the form of ATP to cause those muscles to contract with inspiration. With expiration, if you don't have a lung disease, if you don't have emphysema, if you're healthy, it should be entirely a passive process. So really all that should happen with expiration is your diaphragm will relax, and when it relaxes, it goes from that contracted, flattened state back up to the dome-shaped shape, and it's going to decrease longitudinally the volume of the lungs when it does so. The other thing that happens with expiration is your external intercostals relax. When they do so, they stop pulling the rib cage out. They stop causing the rib cage to flare out. The rib cage collapses back down, and you get a decrease in the volume of the thoracic cavity and the lungs in that particular plane as well. What we need to do is we need to make the thoracic cavity and the lungs, the volume in there, small enough that we can increase the pressure about 1 millimeter of mercury above atmospheric pressure. So if you're walking on the sea, your atmospheric pressure is 760, we need to decrease the volume in the lungs and in the thoracic cavity so that we increase the pressure to about 761. And when we do that, now we've got a pressure gradient. Air is going to move from that area of higher pressure within the lung to the area of lower pressure, which is outside the body, and you're going to exhale.